Right, so we're going to talk about confidence intervals. So what a confidence interval is going to do is it's going to take some sort of point estimate, so you have some data. You'll get either a mean or some proportion. And based on that mean or proportion, you'll be able to make a decision about the proportion of the entire population, right? So, and you'll just be able to say, hey, we're confident that the proportion of the entire population is within this range. So that's what we're doing with confidence, okay? So today we're going to be able to do, well, not today, but probably over the course of this particular lesson, we're going to be able to do all of these things. So a point estimate is a value that estimates a population parameter. So if I wanted to know the average height of all the students here at Cleveland, then I could get a representative sample of maybe like 40 students, right? And find the mean of that sample. That mean of that sample would be my point estimate, right? And I'd be using that to try to make a conclusion about the mean height of everybody at Cleveland, right? So the parameter is the mean height of all the students at Cleveland. And the point estimate is the mean of our sample. So that's what a point estimate is. In this case, x bar. All right, so let's get an example of what a point estimate is. So you got a social networking website. People can add friends, send messages, and update personal profiles. Wow, never heard of it. That's groundbreaking. So they took a random sample of the number of friends for 40 users. And then we're going to find a point estimate for the population mean. And I guess this actually came from the Facebook. And these people don't have very many friends. Okay, so what is this, right? So we're trying to find this sample mean, and we're going to use the sample mean to estimate what the actual mean is, right? So we've got the sample, and if you add them all up and divide by the sample size, you get that you have a sample mean of 130.8 Facebook friends. Ooh, I guess we're going to have to do this one. Find a point estimate. You're going to find the mean of this, right? You guys all know how to find the mean. Now we can add all these and then divide by the sample, right? So we just add each of these up and divide by 30. That would give us our sample mean. I don't really think that's something we need to do. I think that's something we've done. So we'll wind up with an interval. I think we're going to skip this because I want to just get confidence. All right. Okay. So. This is an interesting way to look at it. I'm going to show you a different way. Okay. It's much simpler than that. We're gonna simplify it quite a bit. So if we're looking for a level of confidence of 90%, right, we're 90% confident that the interval contains the population mean mu. What that means, like if you're to interpret your level of confidence, it doesn't mean, number one, that there's a 90% chance that that's what it is. Definitely not, okay? So you never want to, it's not a probability, okay? What that 90% is saying is that if you were to take, for instance, with the Facebook thing, right? If you were to take a bunch of samples, size 30, right? And you calculated a confidence interval for each of those, you're saying 90% of the time, the actual mean of the population would be contained in that interval, right? So that's what that 90% means. It's not a probability or anything like that. It's saying that 90% of the time, if you were to take that same sample size, you would wind up with a confidence interval that contains the truth. I will actually get us these z-scores. We'll get them from a t-table. So our sampling error is the difference between our point estimate and the actual parameter value. In other words, it's saying, hey, how far off from the mean is this sample mean that we got, right? However, we usually don't know the mean of the population, so this isn't something that we're going to actually be. All right, this is actually quite important. Your margin of error essentially is going to give you your upper and lower bounds of your interval. Okay? So it's going to tell you how far away from your point estimate your lowest possible value is and your highest possible value. And so, this thing right here this is called your critical value. So, critical value. That's what that is. We will find that using the Z table. I'll show you, sorry, your T table. I'll show you how to find that. It's the easiest way to find it. And then this here is your, the sigma divided by the square root of n is called your standard error. So your margin of error is going to be your critical value times your standard error. Okay? That standard error, have you noticed it's the same thing as your standard deviation, right? Of a sample. So that's all you got to do. And we'll talk about where to get these critical values in just a minute. All right, so let's do it right now. Let's find the margin of error. Let's fix this. It's quite slow. Can I fix it? No. It's not allowing me. Let's look at this margin of error. All right, so remember we said our margin of error, I'm going to write that as ME. That is our critical value in this case, Z star, our critical value, times our standard error. So I prefer this formula over everything right there. Okay? Now where are we going to find Z star? Alright, so the method that I like to use for getting that Z star is I like to look at a t distribution. We'll talk more about a t distribution later. But for now, what the t distribution is what it is useful to us for is finding critical values. So, if my confidence level is 90%, I'll look at this Z star value, and this is going to be my critical value for 90%. So that very bottom row, that's where we're going to find all of these critical values. Right? So for instance, in our case here, we have a 95% confidence interval. So then this Z star value is going to be, at 95, it's going to be 1.96. So that's how we'll find it. Okay. So here we go. So it's going to be 1.96 times, it's saying that the sample standard deviation is about 53.0. So that's what they calculated the sigma divided by square root. So we'll get 1.96 times 53. So our margin of error is going to be 103.88. So it's just running us through this. We found the critical values. It said that our sample standard deviation was 53.4, not the standard deviation of the population. Alright, so let's fix this calculation. So I was thrown off because it gave me this, but it did not give me n. So I assumed then that this was actually that this was actually that. So that's why I didn't do. I mean, it didn't tell me. It didn't give me a sample size, so I didn't realize it was referring to the previous problem, which led me to believe that this had actually already been calculated, and that was the 15. So it turns out that wasn't true. All right, let's go again. All right, let's find the margin error, and now I think we'll be given all the information. All right, here we go. What in the world is going on with this? Alright, so we're going to do this thing from scratch, assuming that we haven't been given any of the other stuff that we haven't been given the mean, we haven't been given the standard deviation of the sample, and we're going to do this from scratch. So I'm going to go back to the try it yourself one. We're going to enter all that data in a table. We're going to get it to give us the mean and the standard deviation, and then we'll calculate our margin of error. So here we go. So I got to go all the way back to try it yourself one. There it is. And what I really need is this data right here. I'm going to go ahead and put it into a list and spreadsheet here. We'll call this thing Friends. Come on down and we'll start entering in the data. Oops. All right, here we go. All right, here we go. So, 162, 249, 146, 95, 145, 114, 135, 214, 156. All right, so I've entered all the data into my list and spreadsheet. And now, it's been a while since we've done this on the calculators. I'm going to hit Doc, Insert. I'm going to put in the calculator. From this calculator, I'm going to get my mean and standard deviation of my sample. I'll hit Menu, Statistics, and I want stat calculations, one variable stats. And I got to choose a list. Remember this? This was from a long time ago. I got to choose just friends. I go all the way down to the bottom. And it spits out all this awesome information for me. Most importantly, I get X bar, 138.5, and I get the standard deviation of my sample, which is 51.046. That's the stuff that I needed in order to do this. So now I can go back to where I was being asked this question and try it yourself too. Yep. So my margin of error is equal to my critical value times the standard deviation of my sample over the square root of my sample. So, first of all, critical value, we'll get to our t table. And at 95, we decided that was 1.96, right? So there we go. So we'll put 1.96 in here. The standard deviation of my sample we determined is 51.046. Divided by the square root of our sample size, which turned out to be 30. All right, let's go ahead and calculate this thing. So, 1.96 times 51.046 divided by that. Here it happens. Alright, so that turns out to be 18.26. So there is our margin of error. All right. Okay, so I'm not a huge fan of this one. Give you a different one, okay? I like every single time, right? Every single time that we're gonna do this, that we're gonna create a confidence interval, it's always gonna be our point estimate. In this case, the sample mean, okay? So point estimate plus or minus our critical value times our standard error, which is actually just going to be the standard deviation of whatever we're sampling. So now in our case, where we're doing it for a sample mean, the formula is going to look like this. X bar is our point estimate. Our critical value that we're going to use is going to be Z star according to this text. Should be T star, but I don't think they're going to give you small samples. And our standard error is going to be a standard deviation divided by square root of 7. So that's the formula. All right, let's do this. So let's go ahead and construct a confidence interval. There's only one more step we need to do. So we figured out our margin of error, right? So our confidence interval is going to be, in this case, X bar plus or minus our margin of error. We already determined in that try yourself too that the margin of error is uh, 18.267. So 18.267. So let's just put that stuff in there now. All right. So we know our X bar. We calculated it here. So 138.5. Plus or minus our margin of error, which is 18.267. So what we're going to do is we're going to calculate an interval. And I know it looks like a set of points, right? But it's not. It's an interval. It's our lowest value and our highest value. And the way we get the lowest value is we subtract. So this is going to be 138.5 minus 18.267. And then our upper value is going to be 138.5 plus 18.267. We'll go ahead and calculate that, and that's going to give us our confidence interval 138. So the lower bound of our interval is 120.233, and the upper bound is 156.676. So there you go. We constructed our first confidence interval. Right? How do we interpret that? It's 95% confidence. So if we were to interpret it, we would say that we are 95% confident sorry about that E, that the true mean number of friends is contained in the interval. $120.233, comma 156.76. And that is the complete answer. And of course they have something. We already did this. All right. Let's do another one. And now our standard deviation is known. All right. We're around sample of 20 students, which means that n equals 20. The mean in that x bar is found to be 22.9. We know that the standard deviation is 1.5. We're going to construct a 90% confidence interval. Okay, so we're going to use our formula that x bar, that our confidence interval is x bar plus or minus our critical value, in this case we'll use z star, times our standard error, standard deviation divided by square root. Alright. We have everything that we need to do this. In this case, x bar is 22.9 plus or minus. Let's find the z star value for 90% confidence. We'll go through our t table. And we'll look at 90% confidence, so right here. So 1.645 is what we need. Times standard deviation that we've been given, 1.5 divided by the square root of n, which is 20. All right. Now we just have to calculate this thing. So, 1.645 times 1.5 divided by the square root of 20. So our margin of error is 0.552 approximately. And now in order to calculate the interval, I'm going to add 0.552 and subtract it. So first thing I'll do is subtract 22.9 minus 0.552. Gives me the lower bound of our interval. And then I'll go ahead and add it find our and that's it. It has been constructed. It's not as complicated as higher text. Pretty straightforward calculation. You're given some data, you're given a formula, plug the stuff in the formula, make some calculations. Alright?